Hey there, and welcome to another episode of Fancy Tech. Be sure to like and subscribe to keep up to date on innovative industries and technology. Engineering and technology has been improving the way we live for centuries and continues to change the way products are designed and manufactured. We have been able to build and expand civilizations by tapping into natural resources using engineering problem-solving skills, which still continues today. With further advancements in these fields, professionals in design and engineering roles will see changes to their job duties, be challenged to acquire new skills, and learn new ways of collaborating with machines. New communication technologies will link up machines much like cellular technologies interconnecting humans. Automated manufacturing will allow us to scale up our production levels to meet global demands. And a broad range of engineering technologies to make power more abundant, efficient, and eco-friendly will sustain our growing population, which is expected to reach 11 billion by the start of the 22nd century. In this episode, we're going to discuss some of the most advanced engineering technologies that are set out to further evolve the world as we know it. 5G is the faster successor to 4G and is already here. Huawei, Verizon, and AT&T have already started installing their global 5G network for mobile devices, and soon after, the technology will also be incorporated into machines, cars, IoT devices, drones, and infrastructure equipment. That means 5G will allow machines to make long-distance data calls to other mechanical and electrical devices at speeds faster than today's home internet connections. Like its predecessors, 5G is also a cellular network in which the service area is divided into small geographical areas called cells. All 5G wireless devices in a cell are connected to the internet and telephone network by radio waves through a local antenna in the cell. The main advantage of this new network is that it is able to provide greater bandwidth, giving faster download speeds of up to 10 gigabits per second. The increased speed is achieved partly by using higher frequency radio waves as compared to the 4G cellular networks. However, higher frequency microwaves have a shorter range as compared to the 4G network towers, requiring smaller cells, and that is the reason why 5G towers will have to be installed in a closer vicinity to each other without trading off the higher data transfer speeds. Marketed under the name ALON, aluminum oxynitride is a ceramic composed of aluminum, oxygen, and nitrogen. It is also being referred to as the transparent aluminum, a phrase popularized by the 1986 Star Trek film. ALON is more than 80% optically transparent under near ultraviolet, visible, and mid-wave infrared regions of the electromagnetic spectrum. It is 4 times harder than glass, 85% as hard as sapphire, and nearly 15% harder than magnesium aluminate crystals. Having a cubic spinal structure of ALON means that it can be fabricated into transparent windows, plates, domes, rods, tubes, and a lot of other forms using the conventional ceramic powder processing techniques. Its combination of optical and mechanical properties make this material a leading candidate for lightweight high-performance transparent armor applications, such as bulletproof and blast-resistant windows and other military infrared optoelectronics. ALON-based armor has been shown to stop multiple armor-piercing projectiles of up to 50 cal BMG, which can penetrate 3.7 inches of the traditional bulletproof glass. Imagine the power of being able to design and build something virtually to see how everything comes together before you expand real-world resources and then figure out a flaw in the design. You'll no longer have to imagine. A digital twin is a digital replica of a living or non-living physical entity that can help you with that. While the concept for digital twins has existed for quite some time, the adoption of the Internet of Things makes digital twins affordable and more practical. Digital twins are used to create an exact virtual replica of something in the physical world using data and algorithms instead of materials. This technology integrates Internet of Things, artificial intelligence, machine learning, and software analytics. With spatial network graphs to create living digital simulation models that update and change as their physical counterparts change. A digital twin continuously learns and updates itself from multiple sources to represent its near real-time status, working condition, or position. It is being used for the urban planning of smart cities. In the healthcare industry, this technology is being used to anticipate responses of individual patients towards different medications and medical procedures. The technology has also been deployed in Formula One racing cars to evaluate the performance and reliability of these new automobile parts. Generative Design. One of the things that give humans an edge over a computer is their creative thinking, but that is changing as well. Generative Design uses artificial intelligence software and the computing power of the cloud to create design solutions that would never have been conceived by the human mind, or at least as quickly. Engineers have a new partner in designing solutions and can collaborate with generative design algorithms to co-create complex engineering structures with the help of artificial intelligence. To start the process, an engineer gives design parameters to the algorithm, and then the software explores all possible combinations and generates hundreds or even thousands of design options. The engineer then takes those options and explores the feasibility of the design solutions. In some cases, the designer doesn't even have to be human. It can be a test program in a made-up environment of artificial intelligence. Generative designing can create solutions to substantially complex problems that would otherwise require a lot of resources or problems with a larger unknown number of solution sets. Autonomous or self-driving cars are capable of sensing their environment and moving safely with little or no human input. Self-driving cars combine a variety of sensors such as radar, sonar, and GPS to perceive their surroundings. Advanced control systems integrated into these cars help the vehicle to interpret sensory information in order to identify appropriate navigation paths and obstacles. Tesla CEO Elon Musk has said that he expects his company to create a truly autonomous vehicle by the end of 2020, which means that the number of vehicles capable of operating with a lesser degree of autonomy, such as automated braking and lane changing, will become an increasingly common sight. It won't just be for cars, of course. Trucking and shipping are also becoming more autonomous, and breakthroughs in this area are likely to continue to hit the headlines throughout this decade. Experts estimate that widespread use of autonomous vehicles will eliminate 90% of all auto accidents in the United States alone, preventing up to $190 billion in damages and health costs on an annual basis while saving thousands of lives. Safe driving will also reduce the cost of a car insurance. Besides improving our productivity, autonomous driving will also reduce traffic congestion, which directly translates into a higher fuel efficiency since you're not sitting at idle in traffic anymore. Hardware to allow full self-driving capabilities has been integrated into Tesla cars since 2016, and this hardware fulfills Level 5 safety standards of automation put forth by the US Society of Automation. While there has been some incidents of failures revolving this technology, the record set for the most distance covered by a fully automated car is held by Google's Waymo car. A number of companies are competing with each other to optimize the software of these vehicles to further increase their safety. Let's wait and see where this technology takes us. Subscribe and turn on post notifications so you don't miss more videos on emerging engineering technology and much more. Take care.